This question is trying to get at whether you really understand what this whole slope, y-intercept, linear function stuff is, right? It's not an equation that we have to solve. It's not a graph. It's just defining some characteristics of functions. So I'm going to try to describe what these things look like. Remember, the most important equation is y equals mx plus b when we're talking about linear functions. Every linear function can be described this way, as that equation. We just have to figure out what m and b are. So let's talk about a horizontal line first. Then we'll go to vertical and the other things. Horizontal line, if you think about it, kind of looks like this. And let me get some different color on here. It's going to be some line that goes across the grid. And it has a slope that is 0. Remember, positive slope means uphill, negative slope means downhill. 0 slope means it's just flat across. And the y-intercept is a number. Okay, so that's b, whatever it is, the y-intercept. Okay, some characteristics of this thing. You can see in the graph, it has no x-intercepts, because that horizontal line will never touch the x-axis. I'll come back to that in a moment if we need some more of it, but I think that pretty well describes a horizontal line. A vertical line. If we imagine making a graph of this thing, vertical line looks something like that. Its slope is undefined. We don't know what its slope is. Maybe it's positive infinity, maybe it's negative infinity, but it's not a nice number like 7 or 1/2. There's no y-intercept, because a vertical line is not going to hit the y-axis, with one possible exception. You might have a vertical line that is literally sitting on the y-axis, and then you have an infinite number of y-intercepts. But that's not usually the case. Usually a vertical line has no y-intercept, because your x-intercept is a non-zero value. Now, if your x-intercept were at 0, then it would be a little more complicated to describe this. But this is usually the case right here. And then if you have a diagonal line, or let's just say a slanted line, in this situation, we have m is not equal to 0, and m and b are both defined. In other words, there's none of this crazy infinity stuff going on. All right. So let's take a look at this list on the left and see if we've talked some decent amount about these. A horizontal line has undefined slope. So you can see the horizontal line over there. The slope is defined, right? The slope is defined. It's 0. 0 is a defined number. It's perfectly fine. It's not very interesting, but it is defined. So this one is wrong. Excuse me. This is saying find all true statements. So this statement is wrong. And if I say intersecting lines have the same slope, oh, we didn't talk about intersecting lines yet. That's interesting. Intersecting lines look like this. Here's my grid. Here's one line, and here's another line. Now, do they look like they have the same slope? If they had the same slope, they'd be parallel. Let me draw you a parallel example. That one right there. See, green and blue are parallel lines. They have the same slope. They're never going to intercept. But red and green are intercepting lines. They have an intersection point, and because they intersect, you know they're going to have different slopes. So intersecting lines do not have the same slope. To find an x-intercept, you set the equation equal to y equals 0. Didn't get a chance to talk about that one. But when you're looking for y-intercepts, you set x equal to 0. When you're looking for x-intercepts, you set y equal to 0. A function may have any number of y-intercepts. Wrong. It can only have one. It might have none, but it can only have one. And a function may have any number of x-intercepts. That's true. We were mostly talking about linear functions, but you could have a parabola that hits the x-axis several times. And a linear function only has one slope. That's true. It can't have multiple slopes or it becomes non-linear.